Gargi present. हेलो।
हाँ मैम।
ठीक है, अभी ऑडियो वीडियो
मैम बैकग्राउंड का
नहीं, वो तो
कपड़े
मैं कपड़े निकाल लूंगी मैं, पर यहाँ से लाइट वगैरह ठीक है क्या आप देखो, नहीं तो दूसरी पोजीशन पे बैठते हैं।
नहीं मैम ठीक है।
लाइट ठीक है क्या?
यस मैम ठीक है।
ये कंफर्टेबल है, चेयर टेबल है, नहीं तो फिर बेड पे बैठना पड़ेगा, इसलिए मैंने पहले टेस्टिंग के लिए यहाँ बैठी।
नहीं मैम ठीक है, कंफर्टेबल है।
हाँ कंफर्टेबल है।
यस मैम।
मुझे भी यही पोजीशन कंफर्टेबल है। अभी 1 मिनट, ये एक एक्स्ट्रा लाइट है, बंद करती हूँ, देखो अभी अंधेरा है क्या?
नहीं मैम ठीक है।
फिर भी ठीक है, और अभी भी ठीक है, सेम
हाँ
ये लाइट
उतना कुछ ज्यादा डिफरेंस नहीं आ रहा है।
मैंने लाइट सब ऑन रखे हैं।
हाँ मैम व्हाट्सएप करो। मैम आपका सिस्टम का नंबर क्या है? मुझे एज अ को होस्ट करना था आपको, नाम से नहीं
यहाँ
आ
पे
रहा
तो जो
है। 35।
जूम का नंबर की क्या चाहिए आपको?
एक मिनट मैं आपको को होस्ट कर रहा हूँ, आप देखिए ना को होस्ट आ गया क्या? आ गया क्या आपका को होस्ट?
क्या है?
को होस्ट कर दिया था।
कहाँ आता है वो? अभी
आपके नाम के सामने, या फिर आप स्क्रीन शेयर करके ऑप्शन आ रहा है क्या आपको?
है, हाँ
बस
ग्रीन हो
मतलब
गया वो।
सर वो को-होस्ट हो गया है उनका, मैम का।
हो गया, ठीक है राइट।
हाँ सर।
नहीं नहीं नंबर वही है क्या? मैडम का नाम नहीं आ रहा है ना, 358 समथिंग कुछ आ रहा
हाँ
है।
सर नंबर सेम है।
हाँ नंबर नाम
हाँ
मुझे
राइट
भी
राइट
कल से ही नहीं आ रहा है, वो
358।
पता नहीं क्या हो रहा है,
हाँ
सेटिंग में कुछ हो गया है।
यस मैम करेक्ट
आई
है।
थिंक यूजर नेम चेंज करना पड़ेगा मैम।
कशाचा पण?
तर झूम मध्ये आपल्याला आधी लॉग इन करताना विचारतं ना व्हॉट इज युअर युजर नेम.
माझ्याकडे ना कॉन्फिगर्ड आहे आणि ते काही विचारत काही नाही, डायरेक्टली मला फक्त आयडी पासवर्ड विचारतो बस।
लाटकर मैडम को कॉल
मॅम लिंक वरून जॉईन करा।
मैम लाटकर मैडम को कॉल किया?
हा मग त्या लिंक आता बंद करून लिंक जॉईन करू का? मी ऍप वरनं जॉईन केलं म्हणून असं होतंय का?
हा लिंक वरून ओपन करा, तिकडे युजर नेम विचारतात।
बरं बंद करू?
हा
वीडियो का वीडियो बंद कर दो इसका वीडियो क्यों कर क्या बोल रही है? मेरे को करने को बोलो सर। मैं लाटकर मैडम को फोन करेंगे, वो बताऊं कि मेरे नाम पे। अमरुद्दी का कहाँ है? मैम लाटकर मैडम को कॉल किया आपने?
हाँ किया मैंने, बोला कि मैडम ज्वाइन हो जाएंगे।
ओके
देखते हैं 1-2 मिनट इंतजार, अभी 5 मिनट है, फिर कॉल करती हूँ। अभी उनका ही फोन आया था मुझे 4:30 बजे कि हमारा 5 बजे कि 5:30 बजे, सो आई टोल्ड हर कि 5:30 बजे है।
चलेगा, अभी कॉल किया था और रिसीव नहीं किए।
वो रेडी हो रहे होंगे मे बी, उनको कुछ काम चल रहा था, मीटिंग चल रही थी।
मैम गुडीवाड़ा सर को भी मेल किया है।
हाँ मैं इनको एक व्हाट्सएप डाल देती हूँ कि वी हैव जॉइंड।
चलो कार्तिक
हेलो,
डायरेक्टर मैडम आपका Sir, good morning. As per your time.
Yeah, good morning. How are you?
Fine, sir.
So you could hear me, you could see my screen?
Yes, sir. Yes.
Okay. So whenever you're ready, let me know. We'll get started.
Sure, sir.
Yeah.
Okay, let me see
Like
if I
5
have...
minutes we will start. बिसेन सर मैडम को फोन करूं क्या?
बात हुई मैम, उनको पासवर्ड बता दिया, वो भी ज्वाइन कर रहे हैं.
आपने किया?
हाँ, अभी बात हुई.
आपने किया? फोन किया
हाँ,
था?
कॉल किया था मैंने.
अच्छा, 1 मिनट ये सर का स्क्रीन शेयरिंग का निकालो ना, मुझे थोड़ा मेरा विंडो छोटा करना है, वो स्क्रीन
नहीं
दिख नहीं
सर,
रहा.
सर के पास ही अथॉरिटी रहती है. सर, यू हैव टू स्टॉप दैट स्क्रीन शेयरिंग.
मैंने मेरा विंडो छोटा किया था, फिर से बड़ा हो गया वो. इट्स नॉट कंप्लीटली विजिबल. ठीक है, मेरा वीडियो तो ठीक आ रहा है आपको? मुझे कुछ नहीं दिख रहा अभी.
मैम क्लियर है. लाटकर मैडम इज आल्सो देयर.
ओके, वो मेरा राइट साइड दिख नहीं रहा. मैंने छोटा किया था विंडोज उनका, पता नहीं फिर से बड़ा कैसे हो गया. स्क्रीन के साइड से किया था. ओके, ठीक.
लाटकर मैडम आल्सो जॉइन मैम.
Yes.
गुड
Good
इवनिंग.
morning,
Okay,
good
good
evening,
evening,
sir.
madam.
Good evening, everybody. Good evening, Archana.
Good evening, madam. Hello,
Good
Dr.
evening, one
Gudivada.
and all.
Yeah, yes. Good morning to you all.
Okay. Yeah. Good morning as for your timing.
Okay, so yes, good evening for you, correct. Yeah, good morning for me.
Good
Okay,
morning,
so
sir.
yeah, good morning. How are you?
I'm all fine. How are you?
Yeah, I'm doing great. So great to hear your voice
And
after 5-6 months.
how is the
So
baby?
she's doing fine. She's she's going to be 2 years 18th of this month.
Is it? Oh, okay.
So but I think she's giving all the it's a different kind of trouble, so it's kind of very hard to work from home.
Yeah.
Right.
Yeah.
Yeah.
And give our hello to madam.
Sure, I'll convey that. So I'm trying to sequester myself in a room upstairs, and my daughter will keep coming now and then to knock the door. So I requested my wife to make sure she doesn't knock the door. Right. Okay, so whenever you're ready, we could get started. So basically, I'm waiting for you to tell me when is a good time to start.
Yeah. How is Corona
Yeah,
doing
shall
in your area?
Oh, it's bad. In the US, I think, as you noticed, there are more than 110,000 deaths.
Yeah.
More than
That's
2 million
terrible.
people tested positive. And in our state, actually, it's increasing every 3 weeks. The number of cases is doubling.
Oh,
Right.
take care, sir.
Okay, thank you.
Okay,
It's
stay
nice
safe.
talking to you. Yeah.
Yeah.
So, Bisan sir, shall we start?
Yes, ma'am. Samruddhi.
Yes, sir.
Okay.
Good evening, one and all present online. I, Samruddhi Deshpande, on behalf of MGM's College of Engineering Nanded, extend to you all a hearty welcome. Respected Director, Dr. Mrs. Geeta Latkar Madam, Head of CSE Department, Dr. Archana Razurkar Ma'am, all the dignitaries, our distinguished speaker, Dr. Venkat N. Gudivada, participants, teachers, and dear students, a very warm welcome to you all. After 2 successful national tech webinars, we are exceptionally enchanted with the huge response got and to continue onwards. We present you a series of international webinars. Department of CSE is extremely delighted to present you today's webinar, Solving Large-Scale Relationships, Rich Data Problems Using Graph Database Systems by Dr. Venkat N. Gudivada from East Carolina University, USA. Dr. Venkat N. Gudivada is an engineer, an academic visionary, leader, a capable administrator, strong researcher, industry consultant, and a scientist with MS and PhD degrees in computer science. His professional experience spans over 32 years. His current research interests include cognitive computing, natural language processing, big data analysis and management, NoSQL and new SQL series, validation of SQL queries, high performance computing, personalized learning, automated question generation and assessment, computer science and engineering, and of course, education. Dr. Venkaten Gudivada is such a dynamic personality that it requires another few hours for his introduction. I once again extend a heartiest welcome to you, Professor. Well, now limiting myself to begin with, may I request Dr. Archana Razurkar, Head of CSE Department, to give a brief idea about today's national webinar. Archana ma'am,
Yeah.
over to you.
Today's distinguished speaker, Dr. Venkat Gudivada, who is professor and chair in the Department of Computer Science and Engineering, East Carolina University, USA. Our respected director, Madam, Dr. Mrs. Geeta Ladkar, my faculty colleague friends and dear student friends, a very good evening to you all and good morning to Dr. Gudivada sir, since it is morning in USA. First of all, I would like to extend a warm welcome to you all to this third webinar in the technical webinar series, Tech Talk at MGMCEN, and first international webinar organized by our department and our institute. A very good evening to you all on the topic graph databases. So friends, in computing, graph databases are advanced databases. Those are also called as NoSQL databases. They uses the graph structures, edges, and nodes to represent and store the data. NoSQL databases means the databases which do not use SQL, that is traditional relational languages. NoSQL databases has got many advantages such as flexibility, scalability, and high performance. And because of these advantages, they are used nowadays in all modern applications such as mobile, web, and all other latest applications. So friends, it is our great pleasure having Dr. Venkat Gudivada, who is a great academician, as today's speaker for this webinar. I would like to share a very extraordinary thing about Dr. Venkat Gudivada. He has completed his BTech from JNT University in civil engineering. Then he went to US to complete his master's in structural engineering from USA. Then looking at importance of computer science and engineering and his interest, he shifted to CSE branch and completed his MS in computer science and engineering from Louisiana State University. And then he completed his PhD from again Louisiana State University in 1993. So look at his great, extraordinary journey from a civil engineering to heading a department at East Carolina University, USA. So we are privileged, friends, that we are having a great academician as a speaker for our today's webinar on graph databases, which is a very latest concept in computer science and engineering. I would like to thank Dr. Venkat Gudivada from my bottom of heart that in spite of a very pandemic and panic situation in USA, with my one email, he has accepted our invitation happily, and he has made himself available for two webinars. One is today's and other is tomorrow's on machine learning. So thank you, sir. Sir, we remember your wonderful session delivered in international conference hosted by our department in January 2020, that is ICCET 2020. All the participants appreciated very much to your session. So I thought, why not to provide this academic feast again to our students in these COVID vacations. So friends, I'm sure that you will enjoy and learn lot many things from the academic feast provided by Dr. Venkat Gudivada. I also thank our beloved Director Madam for her wholehearted support for every activity we organize, whether it is offline or online. She is always there to help us, to support us. Finally, I thank our faculty coordinators, Mr. Rahul Singh Bisen and Mr. Junaid, and student volunteers who are working relentlessly to make every online event organized by our department successful. Finally, I thank you all, dear students, for your overwhelming response to every webinar. I hope you to continue the same. Thank you one and all.
Thank you so much, ma'am. And well, moving forward, I would like to say Gerald Marvin Weinberg, an American computer scientist, author, and teacher, had said, problem solving leaders have one thing in common, a faith that there's always a better way. Well, how aptly he said. And MGM's College of Engineering is blessed with such a problem solving leader. Yes, I'm pointing towards our respected director, Dr. Mrs. Geeta Latkar madam, who believe that if problem exists, solution too exists. I, with a huge respect, request our director madam to share her feelings and guide us with her enlightened words on this webinar occasion.
Good evening, everybody. Good morning, Gudivada sir. And
morning.
it was a great pleasure to have you for the international conference organized by our Department of Computer Science before 6 months. And it's a great pleasure to have you here today for this webinar. Like, you know that the COVID pandemic has put the whole world to a stall. But then when there is a wish, there is a way. There is a will, there is always a way. And our computer department is just unstoppably, organizing the activities for the students. And today it's extra happiness that they are going international through this webinar organized. And I'm very thankful to you, Gudioda sir, that you have found the time for all of us and are going to enlighten us regarding the solving large-scale relationships, rich data problems using graph database systems. Okay, I don't belong to your fraternity and I belong to mechanical engineering, but all I understand is whenever you are getting the data, you are getting it in the form of some random numbers, structured or unstructured, whatever it is. And the job of the data analyst or data engineer as such is, to put it into meaningful relations, equations, and to interpolate or extrapolate the data as per need and draw some meaningful conclusions out of the data to take the appropriate decisions. So I think this is a very important part of handling the data, and Professor Gudivada is going to enlighten us. I find a very down to earth and humble person, in spite of being, like so much knowledgeable and, working in a good university in USA. Like he is very unassuming and down to earth person. We enjoyed the interaction with Professor Gudivada during the this conference, and like we had told him that we would look forward for having more association with him, and he has made it possible through this webinar. I am very happy and like to welcome you for this webinar, sir. And I congratulate our departmental head, Dr. Archana, and her whole team, Bisen and there is Rahul Bisen and Junaid and like Samruddhi and her team, like all the students, staff coordinators and HOD, all are very much enthusiastic and they are going way ahead, okay, organizing different activities in this situation. That, like I always tell it that like they can stop our body. We could be physically confined, but as long as our mind is free to imagine, our mind is free to work, nobody can stop any human being as such. So thank you very much, sir. Over to you.
My pleasure. Yeah.
Thank you so much, ma'am. Now it is the turn of our distinguished speaker, Dr. Venkat N. Gudivada. Before I request him to start his session, I would like to tell him something. Ashish tu nanu miru e lockdown. Lo Bagu Narani. Now, with great pleasure, I would like to request Dr. Gudivada sir, who is a professor and chair of the Computer Science Department at East Carolina University, USA, to begin with his session. Gudivada sir, over to you.
Thank you. Thank you, Samruddhi. It's nice hearing your voice. I could also relate to face with the voice, and you were really you did an extraordinary job at the international conference introducing speakers and very eloquently talking about the topics and introducing speakers and making a comment after the session. So it's it's really extraordinary skills you have, and you should nurture those skills as you pursue a career after your graduation. I also want to thank Dr. Archana Rajurkar for giving me this opportunity, and also Dr. Vratkar, Director, Madam. I personally enjoyed my visit to Nanded, the MGM College of Engineering, and I was, it's something that I remember for a long time to come. Maybe it's a lifetime event that you remember for the rest of your life. And I thank you for all of you for your hospitality and making that visit a memorable visit. It was truly my pleasure. My family also was there, and we all enjoyed visiting the university, meeting all wonderful people and really bright students. So we have just about if I remember Dr. Archana Rajurkar's time, she said it's from 1.5 hours altogether. So we already spent about 14 minutes, and my plan is to talk for next 1 hour or so, and then have some time to interact through questions and answers. So I'm really delighted that I see almost like 164 participants joined this session. So I'm really privileged and delighted to be speaker for this series. So now coming back to the topic, it says solving large-scale relationships-rich data problems using graph database systems. So I'm not going to actually promise you that you will become an expert in graph database systems in the next 1 hour. But what I promise is I provide you necessary background, the necessary resources that you could build on, and also provide enough motivation why you should consider learning more about graph database systems, not necessarily because you're a computer science student wanting to pursue a career, but also graph database systems have become important for really all kinds of researchers, including faculty members from other departments such as mechanical engineering. So having said that, I have I made about 31 slides, and I had a brief conversation with Dr. Archana Rajurkar yesterday. She mentioned that don't make it too technical, provide motivation, also provide some career guidance in this area. So I revised my slides yesterday so that you could engage in all kinds of audience, provide excitement about graph databases and also career opportunities in this area. I have kept that in mind, and I made 30 slides. Even if I speak for 2 minutes on each slide, that takes us more than 1 hour. Often we underestimate how much time it takes. So I try to keep fewer slides and talk about each slide in some detail, as opposed to really breeze through lots of information. And at the end of the seminar, people ask, what did I learn? Yeah, when I listened to the seminar, it's interesting, but there's not much I could recall now. So let's, I hope I would not go down that path. So essentially we have 5 topics. I'm not going to spend a lot of time on topics 1 and 2, but if I jumped right into topics 3, 4, 5, it wouldn't make much sense. So I just want to quickly go through topics 1 and 2, where you talk, in topic 1, we motivate, the big data applications, and they have given birth to systems in a broad class of systems called NoSQL systems. And then there are 450 at one time. There are more than 450 NoSQL systems, and often, through industry consolidation and shake up the systems and merge, companies now acquire each other. Even now, I believe there are about 400 NoSQL systems. We categorize them into very broad categories. One of those categories is graph database systems. So we very, at a high level, conceptual level, we talk about the data models for each one of these NoSQL class of systems. And we specifically focus on graph databases. And there's a commercial, it's actually open source, but it's also a commercial product, Neo4j. It's open source in the sense that you could download and you create an application, that's open source. But if you really want to build an enterprise scale application where you have, billions of edges in the graph, trillions of, actually I would say billions of vertices and trillions of edges, you need to use what is called Neo4j Enterprise Edition. Then you would actually need to pay money to get those features. Okay, so this is ECU, Eastern Carolina University. We are one of the 17 universities in the state of North Carolina supported by the state taxpayers. So this is our campus. We are unique in a campus in the sense that we have really a comprehensive set of programs, including medicine, dental school, nursing school, public health, engineering, computer science, and all the traditional liberal arts, humanities, sciences, and life sciences, and physical sciences. It's also in a beautiful place in the sense that right now it's season for what you see on the top left, right corner. These are called crepe myrtles. So they actually bloom through entire summer. And if you visit actually next 2 weeks, it looks like the whole city is full of these flowers. So it's a very exciting time, this time of the year in Greenville. The weather is warm, quite nice. So hopefully, some of you come to United States, we'll be happy to host you and visit ECU and, Greenville. We can reciprocate some of the, hospitality that you provided to me. Even otherwise, I think it's a nice for you to visit, and for us, it will be a great pleasure to host you. Okay, so Dr. Archana's on advice. I also want to include some resources for learning computer science. Often, we come from high schools where the top students in high school come to universities, and we feel that we are no longer top students because there are so many other top students, and people get discouraged. That in my high school I was really a star. I come to university, I no longer a star. But that's nothing to be concerned about. Computer science, even engineering in general, they're very difficult domains to learn. There's a lot of math involved, but there are lots of resources available to learn and master these concepts. So I have provided, these are really extraordinary resources. They're available for free. So for example, these are all hot links. If I click on one of these links, it will take me to, this is a website at Brown University. So if you're having difficulty in statistics and probability in statistics, they have really made it quite easy to learn through animations and visualizations. So you have a few other resources like that. So this is a really extraordinary channel. All of them are really extraordinary, but I refer to my students to some of these. And this is each video. For example, there's a video on visualizing Fourier series and Fourier analysis. And there's a lecture on neural networks. These are really several series of short lectures. There's some of it mentioned about Dr. Luthker. She is an extraordinary problem-solving person. So here is tips to be a better problem solver. And there's really quite many essence of linear algebra, essence of calculus, something about hardest problems on the hardest test. I don't need to go through all this, but the author of this series has spent enormous time to create these really captivating videos. So I would encourage you, especially, to learn, to get deeper insights into some of these aspects. So likewise, I'm not going to go into these. Each one of them is really extraordinary or very valuable resource. I encourage you to kind of visit these. I shared these slides with Dr. Rajurkar. She already sent it to you. If you have not received, you can get these slides from her. And also, to succeed in computer science, here are some hints. And I say this to my students all the time. For many of us, English is a second language. No matter how hard you try, it takes an extraordinary practice to gain the same level of performance as your mother tongue. But there are some tools like Grammarly. You write a piece of text before you send it. Even if you write an important email, I would say you just check with Grammarly. It will suggest if there are any blatant errors. That will help you to make your writing more professional. And also some of you may actually know about LaTeX. It's a very professional open source professional typesetting system. Why use Microsoft Word? Everything is free, and often when I produce documents, even if you look at in this PowerPoint slides, we have in a table of the contents at the top. This is done using LaTeX. So Word is fine, but in computer science, you could make your writing more professional by using these types of tools. And if you want to do illustrations, Tixi goes with LaTeX, and that's there's a link to that. And in computer science, if you go for job interviews, and if people ask, have you used Git or GitHub? If you say, I heard the name, but I do not know what it is, that itself could be, really a bad situation for you in an interview. You develop a software in a team environment, and these are open source tools. You could create an account. You work on team projects in your courses, and I would encourage you to know more about Git and GitHub before you go for job interviews. There's also something called a Slack. Is you could have channels within a Slack. This is a way to communicate. A lot of professional software development work, they use Slack channels to communicate. The last thing I really want is an email. For example, in my case, anywhere I get anywhere from 200 to 300 email messages, and often more than 100, 150 email messages. I look at the subject and heading, I delete without reading. Maybe I'm taking a chance. If there's an important email, then it could be devastating if I don't read that email, but you just don't have time. So what we use is we use something called Microsoft Teams, our university licenses for really for all the students and faculty. And we try to avoid an email using some of these professional tools. Slack is open source. You don't need to have a license. And also one great way to learn computer science is to contribute to open source software projects. So there are so many countries, like India and other countries, you can't really license this commercial software. It's quite expensive, very restricting, and students could actually learn computer science by contributing to open source software projects. And teamwork and study groups, when you go to industry, you're not going to work by yourself. Even if you look at your professors, the university, how MGM College of Engineering is run, it's really a team effort. No matter how outstanding one person is, you cannot get any work done just with one or two people. It's really teamwork. So you need to learn how to work in a team. Obviously, all of us are not the same. Some people do more work, some people do less work, some people could be very demanding, or sometimes they could not respect team members. We all need to learn how to work with difficult people and how to make a team work. And also I encourage you to study in groups. Often that somebody understands certain topic much better than other students. But working in a team, you really leverage each other's strength, and that's a very effective way to learn subject and a matter. And if possible, you engage with the professors in doing undergraduate research. If you have time and interest, you talk to your professors. It may not be earth-shattering research. Remember, very few people actually could do earth-shattering research. But we all build on each other. It's more like you want to build a giant wall. If you think about the Great Wall of China, and each brick or each stone contributed to the Great Wall of China. So likewise, any earth-breaking research could come from several little pieces of research. So whatever you contribute, it could actually be quite useful for other people to build on. And if you get a opportunity to go during summertime when your university is not session, going on an internship is a great way to develop expertise in computer science, or it applies to engineering students as well. So as Dr. Latkar madam said earlier, databases have become important. Dr. Archana Rajurkar mentioned that mobile devices, any device, any application you think about, there's no application that exists without an underlying database. So, but there are multiple types of databases, even though many of us only know about relational databases. And obviously, Oracle is quite a popular relational database in terms of market presence. So data is everywhere. The data is produced at a large scale. And we also need to worry about data provenance. For example, think about you want to buy an expensive painting. Some of the rich people, once they acquire lots of wealth, at least in the West, they go about to buy some rare paintings. And if somebody offers me a painting for, let's say, $10 million, how do I know that's the original painting? So likewise, the data has originated at one point, and it went through different transformation points. And I finally have this version of data. I want to be able to track the lineage of data. Where did it come from? Who did, what kinds of transformations did it go through? So that way I have some assessment about quality of data that I'm dealing with. And when I come to conclusions based on this data, if the data itself is shaky, and I won't have much confidence in my conclusions. So you also want to know about where the data came from. Is it a reliable source? What kind of transformations did it go through? And I'm repeating here, rapid rise of data intensive applications. You look at Dropbox, for example, it's a data intensive application. If you look at Google search engines, you look at pretty much any application like Overleaf, which I'll talk about later on. They're all data intensive applications. So with everybody having mobile devices, laptops, and handheld devices, users are contributing data at a phenomenal rate. And then we need to be able to there are many applications that actually take advantage of this data. And we have a new discipline called data science, emergence of data science. And our university, we offer a master's degree in data science. 3 years ago, if you ask which universities offer data science, you could say maybe 5, 10 universities offer degrees in data science. At least I could speak about United States. And if you ask how many universities have some degree program in data science, pretty much every university, every college, they will have some form of data science. In the last 3 years, that is the kind of significance that has been attributed to data. We are having all kinds of data. How do you deal with data, and how do you actually make sense and use the data for very productive purposes? And because of this data science, the governments are collecting lots of data about citizens. European Union came up with a legislation called GDPR. This is in a general data protection rules. And people are concerned about privacy. For example, the technology has advanced to such an extent that somebody could actually write my autobiography without me asking any questions, because there's so much data about myself, and there are tools available that can gather, and then automatically you could write a biography that's pretty much quite close to reality. There could be some questionable things, but that is the state of an art we're dealing with. People are concerned about privacy. Who is tracking me, my movements? People have a right to their privacy. And unfortunately, computer science is contributing to good things as well as bad things. One of the bad things is people are losing their privacy, and every citizen is a fundamental right to protect their privacy. Okay, so what does it mean to me as a student? There are numerous career opportunities as data scientists, as data engineers, as data analysts. But first, now we need to acquire some background in order to qualify for these kind of positions. So this is a very crowded slide. I'm not going to go through every point in this slide. Big data is become a buzzword. You ask any person in the academic world, no matter what the discipline is, even English professors, they talk about big data. There's so much data that's not available. It's too big, too complex to process capture, process store, analyze using ordinary computers. You need specialized computers to deal with big data. People talk about big data in terms of 5 V's. Volume is so high, it's being produced at such a velocity, at such a speed. It's different kinds of data. You have audio, video. Think about how many videos are uploaded to YouTube on a daily basis. And veracity is the authenticity, quality of data, and then what value do we get out of big data. So this is 5 V's, and people talk about terabytes of data, petabytes of data, and even we are heading towards hexabytes. And here are the numbers. In the interest of time, I'm just going to skip this slide. Some of you heard about big data and what it means. So here is some specific examples of big data. So there's in Europe, there's large hadron collider experiments they're doing, and they have 50 million sensors capturing data about nearly 600 million collisions per second. So if you have this data for 1 hour, think about how much data has been generated. Even in 2013, for example, Nobel Prize in Chemistry was given to people who have actually measured and visualized the behavior of 50,000 or more atoms in a reaction that takes place in a fraction of a millisecond. So big data computer science is not limited to computer science, and lots of people in sciences, engineering, humanities, liberal arts, they're all using processing big data to advance science, advance their own disciplines. Okay, so let's move on to the next slide. So where are the NoSQL systems going to come into play? Now you heard about something called Web 2.0. Now 2.0 is being replaced by 3.0. So what is Web 2.0? You can think of Web 2.0 is the second generation web, and 3.0 is really the successor to 2.0. So what is the salient characteristics of Web 2.0, 3.0? It's ubiquitous connectivity. You think about most of us have smartphones now, and you have 24/7 connectivity. So we are connected. All these devices are connected, talking, communicating 24/7. And obviously, this is enabled by network computing, open technologies, and also the intelligent web. You have a semantic web where the data is marked up in a way that you could actually reason about data. So far in Web 1.0, you have these HTML pages. They're mostly meant for dissemination of information. You go to a website, it tells you, about a company, their products, their services, but we can't really do any computing. One example is if you think of, if you ask a question in India, for example, you have so many universities, they all offer a course in, for example, database management systems. If you ask a question, Google, for example, list all the universities in India that offer a course in database management systems during this semester. The information is there, but you're not able to process that query simply because it's not an intelligent web. The information is not encased in intelligent web, but that's going to come through semantic web technologies. So we have social media applications, and many of you may be using Facebook, Twitter, Instagram, YouTube, Flickr. In these applications, users are actually contributing data. For example, if you think about YouTube, the company itself does not contribute data. It's really end user generated, contributed data that makes these applications click. So therefore, if YouTube need to be able to manage these billions of videos and be able to provide a quick search, so that users could get to a video of their interest or need. We also have location-based services. A good example is you're driving, you're driving in a car, and you're running out of gas, and you could actually find, okay, show me the shortest, or the gas station that's the closest. That's a location-based service. Or I'm feeling hungry, it's lunchtime, we want to get certain type of food, show me the restaurants, nearby restaurants that serve this type of food. That's location-based service. And also many companies are taking advantage of location-based services to promote, to market the products, increase sales, and also to enhance their brand development. So essentially what it is there are so many applications that are dealing with large data. We're talking about terabytes of data. And we also want insert and retrieval operations on a very large scale. For example, I have a database. I want to be able to have millions of parallel queries. Will I be able to do that and also respond to these queries in a fraction of a second? Because people are not wanting to wait more than even a second in some cases, and it looks like a long time. If the system does not respond, you cancel that query, move on to other queries. So we have a large number of insert retrieval operations, but we don't have edits. And it's more like this information is inserted and retrieved, but very rarely you go and edit. If you have an edit, need for an edit, it's more like a delete followed by an insert. Okay, so I'm trying to keep an eye on my time. And so what does it mean, given all these applications where you have inserts and retrieval operations dominate compared to edit and delete? And we also have all kinds of data. So what this gives rise to is we need flexible data models. Many of you, if you are computer science students, you have taken a course in relational database management systems. I believe last time I talked to Dr. Achina Rajurkar, that's one of the courses she teaches. And you primarily study things like data modeling, relational algebra, relational data model, integrity constraints, and transactions. SQL is an important part of that course, but that has only one type of data model, that's a relational data model. So relational data model is basically, in layman's terms, you divide the data, you partition the data into set of tables, and when you wanted to synthesize, answer a query, you do join operations across multiple tables. So that has been the major or the only paradigm that has been there overall, for last, I would say, these things started in 1980s. Almost like for 50 years, data has been managed using relational database management systems, and SQL, structured query language, is the default or de facto query language. But unfortunately, what happens is maybe for many applications, it's not a right fit. We need real-time query response. You're traveling, you need to make a decision. Should I take this exit or should I continue my journey? You want the system to say, yes, there's a gas station if you take the next exit, and you have less than 30, maybe 30 seconds or even less than that to make a decision. So you need real-time query response time. You cannot wait 5 minutes, 10 minutes to get a response. Likewise, you have concurrent users, really in the order of millions. If you think about Facebook, Twitter, some of these Instagram applications, at any given time, you have millions of users round the clock. They're actually using these applications. And the data is each petabyte scale. And I said we are heading towards a hexabyte from petabyte. And we want high availability. Anytime you pick up your phone, you would like your phone to function. Likewise, these databases behind the scenes, they're up and running all the time. And also we want an elastic scaling. I wish I could make this in a more interactive session. What I mean by elastic scaling is if I have a startup in a business, even if I have a well-established business, my workloads on the system are going to change. So all of a sudden, there are many users using the system, and at some points the system is not as heavily loaded. And I don't want to acquire hardware resources, have a local installation. It will be very expensive for me. So nowadays, in almost all the companies, I would say they're going into Amazon Web Services or Microsoft and Azure. These are cloud-hosted infrastructures. They provide an elastic scaling. Elastic scaling means all of a sudden, if you need more computing power, we'll provision that dynamically. The moment you have fewer users using your system, we remove dynamically the hardware other resources allocated to your application, so that you are billed for the amount of resources you use, and the needs vary, and the system resource provisioning is dynamic and from that. So we have fast inserts and lookups. Updates are almost non-existent. It's mostly inserts and retrieving. So if you use relational database management systems like Oracle, for example, it's really a square in a peg in a round hole. What it means is it is not the right choice. It's not the right match. So therefore, we need to be able to select a system that's quite appropriate for the application that we have in hand. Okay, so I'm going to take, I promised myself, less than 5 minutes to talk about traditional relational database management systems and how they have given rise to a large number of database management systems called NoSQL systems. So I know, I think many people talk about, Oracle, for example, and maybe it's a dominant system in the marketplace from a commercial point of view, from a job prospects point of view. Knowing Oracle is a plus. But what we do is, we also use, if I'm going to have a startup in a company, I don't have money to pay Oracle for the licensing. Though they do have some provision saying that if you're doing the development work, we don't charge you, but once you start making money, put your system into production, we want you to pay the money. But PostgreSQL is open source. Often people say this is the best embodiment of all the advances in the database world from a relational perspective. And if people are testing like Oracle, Microsoft SQL Server or other types of commercial systems, if their query is not retrieving correct results, they try to run the same query on PostgreSQL. And if it fetches a different result from the result that's fetched by Oracle, for example, they don't suspect the problem is with PostgreSQL, the problem is with Oracle, or the problem is with Microsoft SQL Server. So it's that is the kind of rigor and the accuracy in terms of implementation accuracy that PostgreSQL provides. So it's I would say, even though you wanted to learn Oracle, but if you know PostgreSQL, you have already learned an Oracle. So here is the PostgreSQL database. It's an open source, and you could install on your system and play with it. Okay. Okay. So now what I wanted to do is I wanted to show this more from an educational perspective, and I thought I have already opened my Jupyter Lab. So what I have is this is what I do for my I used to teach in a database class on a regular basis, but now I don't actually teach, somebody else teaches. So here is what we're trying to do at our university is we're trying to reduce at some point completely eliminate PowerPoint slides or using lecture-based way of teaching students. So this is an example of where you wanted to learn SQL. This is called a Jupyter Lab notebook, and if you have not heard about Jupyter Lab, it is actually open source. It's Python. Actually, it's Python-based environment for interactive learning. You could also do reproducible research. You could document reproducible research using Jupyter Lab, and you need to install something called Anaconda. It's also open source, and one of the things that you would see in Anaconda is I thought I had something here. Okay, so I'm a little clumsy here. So when you install Anaconda, you actually get, this is what I just did, lots of other applications. So I'm not going to worry about showing you Anaconda here. So once you install an Anaconda, you get in a Jupyter Lab. You could also run C++ programs. You could run MATLAB. You could run Java, for example. And what we try to do is, we try to eliminate lectures and let students, interactively work. For example, you're learning SQL. Okay, I'm not going to go through whatever I have. The students are supposed to read this before they come to the class. And for example, we want a hands-on experience for students. And here is a relational schema for this exercise. And let's say you wanted to do simple SQL queries, and here is a cell in JupyterLab. The document is divided into cells. So a cell can actually contain code. A cell can contain markdown. It could be HTML. It could be actually any kind of markdown that the system understands, or it could be a raw cell. In this case, it is a code in a cell. So I could run this piece of code. Obviously, my system went to sleep last night, so I needed to run the previous cells. I need to import some libraries, load the database in a driver. I need to provide credentials to connect to my database. And now if I go back and say, okay, here is a query that I have. I have a table called employee, select everything from employee table using this connection, and read that whatever data that you get, store that into a data frame. So that's what we're doing here. And it did store into the data frame. Now I could say, okay, show me the first few lines in the data frame. This is the result of executing my SQL statement. So here is my result. It showed me only the first 5 rows. Actually, yes, first 5 rows. And you could also look at your entire data set. So here is the entire data set. Likewise, we have several things in this JupyterLab notebooks. So what we are trying to do is, if students are kind of taught using PowerPoint slides, maybe they fall asleep, or they may slip into surfing Facebook or Twitter, wherever they like to go. And we try to engage students when they're learning SQL. We don't have the distinction between lecture and lab. All these things are happening at the same time. So that's this is the direction we are taking in our department to really remove lecturing and replace lecturing with the interactive activities where students have to really get engaged. For example, here is okay, here is a query that you did, and then here in this cell, as a professor, I could give a problem to the students. Okay, now it's your turn. You write your SQL query. You could execute the SQL query right here. If there's a syntax issue, your professor could come and help you, or a teaching assistant can come and help you. And so this way we find students are more engaged in learning. Okay, so this is what I was going to show you. When you install Anaconda, it provides a JupyterLab. There's so many other things in a Qt console, notebook. I do not know many of these things. The only thing I use is JupyterLab. Okay, so that's okay. I thought I would. I think I said maybe more than 5 minutes. Okay, so the resources that if you want to learn more about NoSQL systems, this is a special issue that appeared in IEEE Computer on big data. And here is a lead article that I wrote with the 2 other professors on big data promises and problems. And we also had a detailed article in IEEE Computer that came about in 2016. It's called a Renaissance in Database Management Systems, Data Management Navigating the Landscape of Candidate Systems. And it's kind of interesting, we actually finished this work in 2013. It took 3 years for this paper to get reviewed. We went through almost like 7 revisions back and forth with the reviewers. Finally, they accepted this paper. It has come to a point where I felt, okay, I'm not going to waste my time. I'm just going to give up. But then, okay, I have spent so much time. If I give up, it's all wasted. So we persisted. Finally, it got published. But I'm not blaming the reviewers. It's actually a nice thing that the paper improved. But again, you have limited time. If you have to go through 7 revisions over a period of 3 years, it's just a lot of time just for one paper. Okay, but overall, it came out to be a good paper. So here is NoSQL landscape. You might wonder, where do NoSQL systems fall in place? So you can think of relational database systems as, here I have shown this as a Venn diagram. So here is relational database systems which use SQL. Then what happened is then NoSQL systems came into play, and NoSQL, as Dr. Rajurkar pointed out early on, that these systems do not use SQL as their query language. They have their own query language. For example, Neo4j, we're going to look at Cypher as a query language. That's appropriate for querying graph databases. So these systems are called NoSQL systems. And then relational database vendors like Oracle, for example, Sybase, and Microsoft SQL Server, they sensed, okay, there's a momentum here towards NoSQL systems. If we don't change, we may not exist in the market. So therefore, some systems came into being where it's called new SQL. They will have the features of relational database management systems. They will also have some features of NoSQL systems. So therefore, it's the best of both worlds. We could provide relational database capability because there's so many applications already done using relational database management systems using SQL as a query language. But we could also incorporate NoSQL. Such systems are called new SQL. So again, it could be quite confusing. So to give you an idea of where these systems are, so here is a website, web application, I would say, that actually tracks all NoSQL systems. For example, here, so these are the most popular database management systems. And I felt, okay, there should be somewhere systems. Okay, here, if I click on systems, so these are the database management systems that are available for, for data management. So you would wonder, how do I know if I have this many choices? How do I know which one is the right choice? Okay, I don't have time to really learn about each one of these systems, and it's so therefore what we have done actually in the research area, they have created, for example, they have created. They actually partitioned these NoSQL systems into various high-level categories. For example, you have relational DBMS here, and these are all the relational databases, relational database management systems. And they actually, this is the June 2020 ranking. So this is the May 2020 ranking. So then in June, the ranking actually, it went up. They have some way of calculating the score, and you could read about it somewhere on this website. They talk about how they compute the score. So obviously you have Oracle because of the commercial establishment, they're the first, I would say, IBM had System R and IBM DB2, but Oracle somehow captured the market. And they have been in this for, I would say mid-1980s. So it's almost like 35 years. Because of that established base, they're the leading. And if you look at 10 years from now, I really wonder whether Oracle will be number one in relational space. Now, if you look at database model, they call it's not only relational, it's also multi-model. That means they're trying to incorporate, or they have incorporated some of the NoSQL system features into this model. That's why they call it multi-model. And they could claim, yes, you don't need to go to Neo4j. We could also be a database for graph, managing graph data. So likewise, if you look at MySQL, it's open source in some sense. I have not used MySQL in a long time, but that seems to be quite popular because it's easy to use. So that's also number 2 right now in relational. Then Microsoft SQL Server is in number 3, and PostgreSQL I talked about is number 4. And many academic institutions and also startup companies, they use a PostgreSQL. MySQL may not have the rigor and some of the features that you need, but if you want simple websites and data-driven websites, that's where MySQL's popularity comes from. A lot of people without any background in relational databases, they could actually start using a MySQL in a couple of hours in a time. So that's why it's kind of popular, because so many people outside computer science use MySQL. PostgreSQL, you require a little bit of a relational database in a background to properly use in a PostgreSQL. Now, IBM DB2, the list goes on. So likewise, if you look at time series databases, document stores, you heard about MongoDB is the most popular document-oriented database. It's one of the NoSQL systems, and you have so many of them here. So likewise, you could talk about key value stores. Redis is the leader, and again, there are many systems for key value. These are all classes of NoSQL systems. So we're going to focus on, for example, graph DBMS. So here is the graph in a DBMS. And obviously, Neo4j is the market leader. In one way, it is open source. In other ways, it's not an open source. If you need basic features, it's free. If you want enterprise features, it's not free. So then again, Microsoft Azure Cosmos DB is also, you can use it for graph database, but it's not purely graph database. So it's a multimodal. So if your data is in a purely graph relationship data, I would say you would use a native graph database system such as Neo4j, and Janus Graph is also purely a graph data management system. Then dgraph, there are a few things like JGraph, Tiger Graph, and a few other things which are based on the graph data model. Whereas many other systems, even though they're popular, they think of a graph data model as one of the models supported by the database system. So I don't want to say anything more about it. This is the DB Engines website. So that's a hot link, and you could go there to study. There's also another place that you may want to go to. This is a competition to DB Engines. It's called a NoSQL. It also provides more very up-to-date information about what's happening with the different vendors and also with different NoSQL systems. Okay, so that give you enough. I'm going to skip this slide, and only thing I wanted to emphasize here is there's something called a CAP theorem. So if you go for a job interview, very likely if you say I know a little bit about NoSQL systems, or I know NoSQL systems, they may ask, is an interview question, CAP theorem. Do you know anything about CAP theorem? So CAP actually stands for consistency, availability, partition tolerance, and all these NoSQL systems. One way to evaluate NoSQL systems is using a CAP. What kind of consistency levels do they provide? What about availability? Is it a highly available system? And partition tolerance is, these are all networked. All these systems are they're distributed database systems, and they depend on the network for one node to communicate with another node. So what happens? There's a network failure. A system A, or distributed database system A, is unable to talk to distributed database system B. So can it still function? So if you think about, I'm not a Facebook user, but let's say in Facebook, you could also, work on a post. You're traveling, you're sitting in the airport or railway station, and you're working on a post, but you don't have a network connection. But you can still, if the system still allows you to create the post, and the next move, whenever the earliest time that you get network connection, it could connect with, let's say, Facebook and a server to post your blog or writing. So that's partition tolerance is the system is able to perform at a degraded level of performance even without network connectivity. Availability is, what if I have a 5-node in a system, 2 nodes in a fail, is the system still available? Maybe the performance is degraded, but the system continues to provide functions, even some nodes and some hardware failures. So consistency refers to, in a distributed system, you have multiple copies of the data. You do it for high availability. If a node A goes down, the same data is available in node B. So my system could actually read data from node B. So in order to provide high availability, you may have you have multiple copies of the data. So if you make an update to one copy, you want to make sure that you're updating all other copies as well. It's like you have 5 clocks in your house. If each one of them is showing a different time, you have a problem. You don't know what is the correct time. So if you change in a time on one clock, all other clocks need to be changed so that they all show the same time. So consistency refers to if I have multiple copies of the data, or they all agree with each other all the time. Even if they do not agree for a short period of time, you want to bring them to agree as quickly as possible. So if you want to look at NoSQL systems, one way to evaluate them is based on CAP, consistency, availability, partition, tolerance. There's also a I want to exercise a caution. This slide was made in 2012. So what I'm trying to illustrate here is you can think of NoSQL systems as points in three-dimensional space. So you can think of an x-axis as a consistency, and y-axis as a partition tolerance, and the z-axis as availability. So depending on how well they support a consistency, availability, partition tolerance, they occupy a point in this three-dimensional space. And I said, I wanted to exercise caution. So many things have changed since 2012, 2013. And also products rapidly evolve. For example, Oracle provides, let's say, high levels of consistency and reasonable availability. It may not provide partition tolerance because it is, if this is in a Z, this is x-axis, this is the XZ plane. So these, in other words, these Oracle, DB2, SQL Server, Postgres, they provide a high availability. Actually, PostgreSQL provides, let's say, high availability. It also provides high consistency, but it's not providing partition tolerance. So this is one way to analyze. If somebody could plot this correctly and say, okay, you have an application, which one do I use? You know your consistency requirements for your application, you know your partition tolerance, you know what availability you need, and then go into the space and pick one that closely matches your requirements. Okay, so there are several NoSQL systems. In the interest of time, I'm going to skip into the slide. You hear names like Bigtable, Hypertable, HBase, MongoDB, Redis. Then DynamoDB, CouchDB, Cassandra, SimpleDB, Voldemort, React. So each one of these they strive for consistency and partition tolerance. These systems strive for availability and partition tolerance. So therefore, which one you pick depends on to what degree they provide support for CAP. So NoSQL systems, there are 400 plus of that many of them. They significantly vary in functionality. For example, React is highly scalable and available, but it won't provide partition tolerance. MongoDB has certain other characteristics. Neo4j excels at managing data that's rich in relationships. So if my data is predominantly relationship data, then Neo4j is the right one for me. Redis it provides lots of data structures and elegant query mechanisms. Like HBase, with extreme scalability, reliability, and flexibility. However, it features come with considerable complexity. You need to really know distributed databases theory well to effectively configure and use. So one thing I said early on, we have not yet gotten into Neo4j. We'll get there in a few minutes. What you notice about NoSQL systems is, yes, I have installed Neo4j on my desktop. I'll be showing, okay, here is my Neo4j desktop running on my desktop. Yes, you could run any SQL system on a desktop or a laptop, but there, you're not really going to realize their full potential on a desktop. Okay, so what you need is a distributed computing. They're meant enough to be installed and run on a distributed computing architecture. I'll show you in a quick second what is a distributed computing architecture. They provide different types of data models and query languages, and also consistency models. They have different levels of consistency, and each class of systems target a category of application. But unfortunately, what's happening here is market leaders like IBM, Microsoft, Oracle they obviously need to promise something to their users. And don't go to Neo4j or no, don't go to some other system. We have all of that can be delivered right in Oracle, for example. But we being in computer science, you don't want to listen to marketing literature. You need to evaluate whether the system has the capability that they claim, right? So that's one of the lessons that I learned in industry when I worked for 6 years in Wall Street, is when you want to evaluate a system, you really need to do your own evaluation. If you listen to the salespeople's talk, yes, you describe your problems. They say, yes, my system can do this. Yes, my system can do this. No matter what you say, they're going to say, yes, we could do it. But you don't want to commit. You want to do your due diligence. You need to evaluate internally and assess to whether that's a good fit for your application or not. Okay, there's another thing, this is a very popular phrase in NoSQL systems, and performance at scale. For example, if I have only 10 records in my database in a table, performance is instantaneous. I type in any query, I get result right away. What if I have 10 million rows? What if I have 100 million rows? What if I have 2 tables that are each has 100 million rows, and I have a join query? How does it perform? Does it perform? Performance at scale means as your data grows in size, the time it takes to execute queries remains the same. Okay, so it's an ideal goal, but it may not be the same, but it may increase. But it can increase from, let's say, 30 milliseconds to 60 milliseconds, but you don't want it to increase from 1 second to 1 minute. So then it's not performance at scale. Okay, so this is what I was talking about. NoSQL systems are meant to be run in a distributed computing environment. So we have a data center 1 here, data center 2 here. Each data center has multiple racks. Each rack hosts different nodes. These nodes are standalone. They have their own memory. They have their own disk space. They do communicate with each other through networking. But you also have cross data center network, computers in one data center talking to computers in another data center. So this is a very specialized topic in the sense that you need some specialized people, hardware, specialty people. They know how to configure these racks, nodes in a rack, also how to run a data center. So as I said, you could try them on a laptop, but the true capability is not going to be achieved on a laptop, or you cannot even demonstrate their capabilities on a desktop or a laptop. So there are the key to this is there's something called a shared nothing architecture. So what that means is each one of these nodes is independent. They don't share memory. They don't share disk space. They communicate with each other through message passing. That's one way of communication. So what is shown here on the left hand side is all the requests, service requests come through a master node. It's more like a load balancer. And these are all the worker nodes at the bottom. And whenever there's a service request, the master node knows what is the current workload on each one of these worker nodes and assign that request to one of these nodes. The danger here is one single point of failure. If master node breaks down, then the entire system crashes. You won't be able, it's not available. So therefore you have a standby master. It keeps checking on the master node. As long as the master node is healthy, it's going to rest. As soon as it senses the master node is dead, it will take over the responsibilities after the master node. So conceptually, this is a very simple architecture, but to implement, it requires a lot of skill. So on the other hand, if you want to avoid single point of failure, here is another architecture. It's called a master-master shared nothing architecture, where every node is equal. Every service request can be sent to any one of these nodes, and they communicate with each other to get the work done in a collaborative manner. So here again, conceptually, it's very simple that in practice, you need special expertise to maintain a cluster, install software in a cluster, and make it work. Okay, so I'm going to actually move on. When people talk about this, another interview question in databases, relational databases, when you talk about transactions, you probably came across the acronym ACID. A stands for atomicity, C for consistency, I for isolation, D for durability. In short, if you run a transaction may consist of multiple computational steps. Atomicity refers to all these steps run as one unit, or if any one of them fail, you need to undo to a state where none of these steps got executed. Consistency is if you have multiple copies, you want to keep the data consistent across all the copies. In other words, even if you don't have a distributed system, you have a copy of the data. For example, you changed somebody's salary. It may be remaining in your main memory, but the same data item is also on the disk. You changed in the main memory, but there could be a crash, and then you end up, you promise the user you changed the salary, but the changed value from the main memory did not make it to the disk. Okay, so that the consistency could temporarily exist even if you don't have a distributed database. Isolation refers to you have multiple transactions, they're progressing at their own pace. You don't want one transaction to interfere with the execution of another transaction. Durability says, once a transaction is committed, rain or shine, let there be a thunder, let there be an earthquake, let there be a flood, it doesn't matter. The system must guarantee that the data is persistent. Now, once you tell the user, yes, and I changed the salary item to the new value, no matter what happened after the time, you want to guarantee that the durability guarantees that the data is persistently saved. So, people say, those who have implementation experience in relational database systems, almost 70% of the difficulty of implementing a relational database system comes from implementing transactions in such a way that they satisfy these ACID properties. So when it comes to NoSQL systems, it's kind of not real acronym, but they said, okay, ACID, we need to somehow make acronym sound in a base. Okay, ACID base. So base stands for basic availability, then S for soft state, then E for eventual consistency. So what it refers to is eventual consistency refers to is given enough amount of time, all the data in the system will be consistent. So then given enough amount of time, what is that amount of time? Is it in a few seconds? Is it few days? Is it few weeks? So you need to study the systems, when they talk about eventual consistency, how long will it take for that eventual consistency? Okay, so I'm not going to go into the details, but if people said, okay, about SQL systems, NoSQL systems, what is in a base? So that's basic availability, soft state, and eventual consistency. Okay, so here are the various classes of systems we have. We talked about this earlier when I went to DB engines. We're going to dive into NoSQL systems. Okay, so before we do that, I said very early on, you're not going to become an expert in 50 minutes time. We also spend some time talking about other things. We essentially have less than 15 minutes. You're not going to become an expert in 15 minutes. So here are the resources that you have. Here is a hot link, getting started with Neo4j in 10 minutes. Actually, it's really 10 minutes. It includes installing Neo4j, doing a basic data insertion, and doing a query. So which I'm going to show you in subsequent slides. So here is it's hot link. You could read that article. Then here is a graph databases for beginners. I believe when I shared this document with the Dr. Rajurkar, she might have emailed it to you along with the slides. If not, here is the place where you could download this document. It's about a 48-page document. It walks you through what is a graph database, installing, inserting some data, doing some simple queries using Cypher. There's also another book, more elaborate book. This is about 250 pages, graph databases, published by O'Reilly. It's a legal free download from Neo4j, and you could download this book as well. There's lots and lots of free online training and certification for Neo4j. I'll probably just click only on this link. Okay, so here is introduction to Neo4j, 16 hours of training, graph data modeling for Neo4j, 4 hours of training, implementing graph data models in Neo4j. There are really lots of good resources, obviously, to learn anything new you need in a time. So how to implement, how to administer a Neo4j server. Here is administration details, and here is another 12 hours. So this is really a good resource because of the COVID and a downtime. Since you're not going to classes, worthwhile to spend a couple of days to learn this NoSQL databases. Okay, last one, Neo4j, how to best practices and customer stories. These are again YouTube videos, a lot of them about how graph databases have been used. Okay, so where do you use in a graph databases? Okay, so let's talk about scenarios. Okay, where do you find uses for graph databases? So here is when you want to understand relationships. Okay, here is my highlighter. You want to understand relationships between entities, relationships and rich data. For example, we are building a system for personalization of learning. It's called interactive system for personalization of learning. So what we are trying to do is, you wanted to study a course, like for example, relational databases. Right now, the way students learn a course is, a professor tells you, okay, week 1, we're going to do this. Week 2, we're going to do this. And professor decided the sequence in which you're going to learn the topics. And that's the sequence in which you're going to learn the topics. But what we are trying to do is, I recall my own experiences when I was an undergrad student. I actually studied, one of the courses was computational fluid mechanics. It was such a beautiful and very interesting course. I still remember the professor, the kind of excitement he created in the classroom. And some of us could not wait for the next class because it was such captivating topic, fluid mechanics. So of course, it has equations, and if you kind of look beyond equations, a lot of beauty comes through. So anyway, we are what we are doing is we are building a system, iSpell, in a system where students could actually pursue topics in any order they like. For example, the reason I mentioned about fluid mechanics is I got interested in one aspect of the course. I wanted to go all the way to the end without waiting for my professor to go through that path. So we are allowing students to learn. They will all learn the same set of topics, but they learn them in a different order depending on their interest, just-in-time learning. So we are using Neo4j for creating prerequisite and dependency graph so that you can learn any topic as long as you have the prerequisite requirement. So when we talk about prerequisite requirements, we're not talking at the course level. If you have data structures 2, your prerequisite is data structures 1. That's in a very coarse. We are talking about a very fine, granular topic level dependencies. Okay, maybe at some point, once the system is in a reasonable state in the next 2 months, at some point I would be happy to do a seminar or a webinar on interactive system for personalization learning, which is actually based on Neo4j. You could also use it for fraud detection. You see this quite often, money laundering. People try to cheat in a public. I don't want to call politicians, all kinds of people actually, if they're given it. Some people always wanted to become instantly rich. I don't really care how I become rich. Whatever method I use, it doesn't matter. But obviously, fraud, government need to prevent fraud. Even credit card companies, a big challenge for them is fraud detection. So graph database is actually come into play. Identity resolution, who you are, you may have multiple identities, being able to decide you're the same person. For example, we have social security number here. We also have a driver license number here. We have passport number. All these identities refer to the same person, but how do I resolve this? Data provenance, tracking data, how it has evolved over a period of time, and also making recommendations. If you go to Amazon, you bought a particular item, it says, okay, you may be interested in these items as well. The next use case is exploring relationships of varying or unknown in depth. So a good example is in supply chain visibility, for example. Right now, that's very much of an issue. Supply chains are disrupted. Some items are not available in stores because of COVID situation. So you wanted to be able to trace, okay, I wanted to make this particular part. Okay, let's see, I can get a pen. I want to make this particular part. It's a complex part. It needs some other parts, okay, this part and this sub part. So then this sub part is made up of these other sub parts. I want to be able to trace, if I want to understand supply chain visibility, in order to make this part, what is my vulnerability, or what is my what I call, I think, exposure. That's the right word. If this supplier gets into some problem, I'm going to be affected. If this supplier gets into some problem, it still affect me through an intermediate supplier. So you could actually model these relationships using graphs. I already talked about discovering lots of different routes or paths. And if in a course, all the students, learners are in the same starting point, and we have different ways of exploring the course, then eventually we end. This is the same starting point. This is the same ending point. You allow the students to traverse this graph, directed graph, in different ways, but they would traverse all the nodes and reach the destination, but they have their own path, for exploration. That's personalized learning, logistics and routing, infrastructure management, dependency tracing, so on. And finally, hierarchically structured data, organizational hierarchies, social influencers, like, this is you in the Facebook, you're friends with these other people, and you could have a query, given a particular node, tell me all the nodes that are directly connected to this node. So these are your direct friends, and your friend will also have friends. Then you could ask a query, okay, given this particular person, show me friends of friends. That's then you have to start at this node and expand to radius of 2. These kind of things can be studied using graph databases. So what are in a graph database? You have nodes and vertices. You have edges that depict various types of relationships. Nodes can have properties, and edges can also have properties. And I'm going to show you an example here. Okay, so I have installed Neo4j on my desktop, and Cypher is a language for creating and querying graph databases. Let's say we said in a graph we have vertex is the main. What vertices? This is vertex 1. This is vertex 2. Vertex 3, and this is edge 1, and this is edge 2. Let's keep it very simple. So we wanted to create a vertex. The way we do it is through Cypher query language. We execute this command called create. I want to create a node. Node X is the vertex name, and it has a label. Label is, for example, I'll illustrate in the slide. You have set of departments at MGM College of Engineering. You have a set of people who work there, and you want to indicate relationship. A particular professor works for a specific department. So you can, labels could be, I have a vertex. This vertex is of type people. This vertex is type in a department. This vertex is type in a research lab. Okay, that's the thing. And then you can have a label. If you have a vertex can have several attributes. If you have a person, for example, what is the name of the person? What is the height of the person? If it's a medical application, what is the weight of the person? What is the blood pressure on a particular date? Things of that kind. So you can have multiple attributes for a vertex. So let's say, to make it very concrete, we wanted to create a vertex called MGM College of Engineering. So this is an acronym, MGM COE. This is a vertex name. It is of type, it's an organization. So the label for this vertex is an organization, and the name is the attribute in a name, and this is the value for the attribute. So I could have many attributes, and for each attribute I can have a value. So even though I did not explicitly create an org as a label, And here the label org is implicitly created because I have a vertex called MGM-COE, and I have an org. Okay, its label is org. So likewise, I'm going to create 3 more nodes, 3 more vertices. And here is a create. So here is AMR. Okay, I just, like Archana M. Rajurkar, I said AMR, these are the initials. There's a node vertex name, and she is a person of type and a person. And right now I have only one name value pair. So now I have another node in a K and K. So I met, your chairperson, Kadam, when I came there. So I recall his name. I met actually so many people. So he is a person, and this is one attribute value pair. So then we have one more, last one, K and K. I'm sorry, when I copied here, there's a risk with copy and paste. So I should have actually changed this to maybe this node name is, as I'm going to use the initial GL. She is a person, and I have only one attribute. That attribute name is name, and the value is this. Okay, so we created, let's say, we created 4 vertices in here, right? We created a vertex called org. We created that org. Actually, MGM-COE is the vertex name, its label is org. And we created 3 vertices, and these are the names of these vertices, and they're of type and a person. So what do you do? How do you create a relationship? Now we're going to create another vertex, is called CSE. Okay, so CSE is that label for CSE is department, because you will also have mechanical engineering, for example. And then I would say ME is also type in a department. It's the label for that is department. So the name is in a computer science and engineering. So in the interest of time, I just want to illustrate how do you create a relationship. So let's say we wanted to indicate the fact Dr. Rajurkar is the head of the computer science and engineering department. So we have a department in a vertex in here that's actually called CSE, right? This is CSE vertex. And we also have a person here, and we call it AMR, that's a person. And we wanted to have it directed in a relationship in here, actually the other way around. Okay, I run into this issue all the time. Okay, so here is my arrow. So we want to show that we want to create this relationship that Dr. Rajurkar is the head of computer science and engineering department to that relationship. The way we do it is, through a SQL. It's called Cypher. Okay, CYPHER. That's the name of the query language, for graph databases, and it's more like SQL. But in SQL we just say select, for example, what are the attributes you wanted to see. Then you have from, which tables does it come from, table 1, table 2, table 3. Then we say where, and here you would actually specify selection conditions in a table. How do I subset rows, and also how do I join? So you could specify join conditions in here. So this is something like this in here. Match means, okay, I wanted to find a person with this. I want to find a vertex with the label in a P, with the label person. That means I want to find a particular person. I want to find a specific in a department. So how do I find them? Where? Find that person whose name is here, and find that in a department whose name is computer science and engineering. So that means we're able to zero in on one particular, in this case, on one particular vertex that is Dr. Rajurkar's vertex, and we are able to figure out one particular department vertex, that's CSE. Okay, that's what we have done so far. So now what we're going to do is, I found a P, I found a specific in a D, and I wanted to create an edge. Okay, so that goes from person, in this case that's going to be Dr. Rajurkar here, and it goes to D, the department is directed. If you see the arrow here, it's actually a direction from person to this department. And the relationship name, So R is a relationship, then colon, then I could specify a name here. So here it says Dr. Rajurkar is the head of a computer science and engineering department. So this may look like a very trivial one, but these are the basic principles. You could create a graph that has, let's say, billion vertices. But am I going to do this manually? No, I'm not going to do this manually. I'm going to generate this script. My data may be in an Excel spreadsheet. It could be in plain text file. I'm going to write a script that will read my data and generate these statements, these cipher statements. And then I can run them from a console. I could actually do a batch processing of my statements that would actually be, that will go into the database. So I'm going to take maybe next 2 minutes, and then, I already exceeded my time. So what I'm going to do now is show you, this is, we created, here is the Neo4j desktop, and I'm going to start a database that came with the installation. Okay, it's taking some time. Okay, so anyway, hopefully it was, okay, so it did open. So I'm going to open the database. So what I have here is, I have some information about, like node labels. So I have, in this case, I have a label called movie. Okay, this Neo4j database is about movies. And I also have a label called person. So these are various people, they acted in movies in the lead role, or some person may be director, some person could be producer, and we have movies. So the relationships are, who acted in which movie? I could answer that question. I could also answer what is the role of a particular person in a specific movie, or tell me more about this particular movie, tell me about this particular director. So relationship types are, okay, acted in, who acted in which movie, who directed in which movie, and follows, who follows whom, and who produced this particular movie. And we have reviews about this movie, and who reviewed this movie, and what is the review, and who wrote in a script for that movie, for example. So these are all the types of relationships. For example, if I look at movies, okay, so here you could actually, these are all, okay, these are all the movies. Okay, so I'm not able to, okay, so these are all, there are 25 movies that are in this database. Okay, I'm not able to scroll, here. So there's movie, there are 25 vertices with the label movie. Okay, so if I click on a movie, for example, or let's say click on this movie, then it actually gives me some additional information about that movie. Okay, so if I wanted to learn about person, I could actually click on person here. So these are all the people who are in the movie database. So there are 25 persons. So let's say like here is a person, Cuba Gooding. So here is how that person is related to various things. For example, here is A Few Good Men is the movie that this Cuba Gooding acted in. And I have information about that movie, If A Few Good Men, and here who are the people acted in. So here Kevin Pollak is one who acted in. There's another person. There are several people who acted in. For example, I wanted to know more about Kevin Pollak. So I could actually go, I don't have any information here, but ideally, you would have information about this. So you could explore this graph interactively, look at different people, what the roles are, how they're related. But for a small size, this is fine. But you could also programmatically explore this through APIs. Neo4j provides an API. You develop a system. You could send your request through that API. It will give you the right information. For example, my query is, if movie name is A Few Good Men, tell me the names of actors and who acted in this movie, or tell me who directed this movie. Or a particular actor, Tom Cruise. So here I could, explore information about this in a particular actor. Okay, we didn't really go into all the details, but what I wanted to show is this is in a very interactive. For small databases, you could interactively explore your data, and you can also programmatically manipulate this data. So what I have not said is how do you use it? You really need to come up with a use case and try to identify vertices, identify types of relationships, and you can manually write your script like what I did here. I just created one relationship, but it could be quite tiring to write the script if you have really thousands of edges. So you would actually write a Python script or some language you going to write that script to generate these statements, and you could run these statements. Okay, so I think we need to stop here. I'll just take 30 seconds and then stop. Actually, I exceeded by 8 minutes at the given time. So we talked about a cap for distributed. Many of these NoSQL systems are distributed database systems. So we use a cap as a guidance. So cap stands for consistency, high availability, partition tolerance are the three primary factors that you need to examine in order to decide the suitability of a particular NoSQL system. Okay, so not all NoSQL systems provide transactional guarantees. So maybe you don't really care about transactions in your application. Maybe in some applications, transactions are needed. So you need to be aware of what kind of transaction guarantees. Do you really need transactions? If you do, then what guarantees does it provide? If transactions are so important, then you want to make sure that you select a NoSQL system that provides transactional guarantees. And the trend seems to be, especially from well-established players, they try to turn their product into multimodal. Multimodal is model. I said maybe model. That's not the right term. Multimodal. That means in Oracle, for example, it could actually be a relational data. It supports a relational data model. It could also support a graph data model. It could also support a document data model. So there's some systems provide multimodal. This may be a good thing. This may be a bad thing. Like myself, I claim expertise in so many different areas of computer science. It's very exciting to be knowing about so many different areas. But my expertise in any particular area may not be as deep as somebody who's exclusive expertise in that particular area. So when you have multi-model database, it does many things, but it may not be able to do great things for a specific area. For example, if you have Neo4j, its only job is graph data models and graph query language. On the other hand, if you go to Oracle, it provides multiple models, but it may not provide the same level of expertise that Neo4j provides for graph databases. On the other hand, you may say, I don't want to install multiple NoSQL systems, and I don't want Neo4j, Oracle, MySQL. I just want one system that is multi-model support. So it depends on criticality of your application. Okay, graph databases provide elegant solutions to a range of applications, characterized by relationships-rich data. So in conclusion, as I said at the very beginning, I'm not going to make you an expert in graph databases in this 50 or 1 hour lecture. What I hope I have done is to give you enough pointers, to go from this point and learn graph databases yourself without investing too much time. So with that, I'm going to stop and turn it over to Samruddhi, or I think she's the one who is conducting the session.
Yes, Samruddhi, please unmute yourself.
Yes, ma'am. Thank you so much, sir, for such fascinating and brightening session. Thank you so much once again.
Yeah, my pleasure, anytime.
Sir, we have queries in chat box.
Okay, so let me
Yes, sir.
answer those. So I need to go into, let's see, where, go into more.
Zoom chat, sir.
Okay, so okay, I'm not able to see Zoom. I'm actually in.
At the bottom of your screen, there is a strip in which chat is written. Zoom
Oh.
bottom.
Sir, please close the screen sharing option.
Okay, okay, let me do security. Okay. So I remove how, okay.
Screen share, just click once.
Okay, stop share.
Yeah.
Okay, okay, got it. Okay, we are good. Okay, so where do, okay, here is the chat, okay. Okay, so I'll just, go through this and see. So please disable annotation. Okay, those are all comments. Audio is low. Okay. So can you help me to identify? I think somebody had a question about there are 3 systems and which one is better. Okay, so here it says, please post your queries. How much of what will analytics play in all of this? Okay, okay, let me start with this in a query. For large organizations, how long will it take to shift their working system for switching from SQL database to NoSQL? Will it be feasible for organizations to switch? So I think, what I would do is, change in general is very difficult, right? Because all of us, don't want, even though we say, okay, change is the only thing that's, not changing, but we all don't want to change because we are in our comfort zone. We like, where we are. So organizations also, they have a lot of resistance for change. But I think the one way to really bring NoSQL systems is, you look at a project and that's not very high stakes in a project. Even if the project fails, the consequences are not somebody losing a job. So I would start with a very simple, non-critical application, and quickly within a week or 10 days, you try to come up with a prototype and be able to illustrate and look at the functionality that we have in a graph database versus, we are using, relational database, for example. You could actually use relational databases to do hierarchical relationships, or even graphs can be encoded, but it's kind of cumbersome. So I think it's possible that education is the key, and implementing a non-critical application would help. I hope I did answer that question. Okay, how much of a part will analytics play in all of this? Okay, so the whole idea of analytics is you have information coming from different sources, right? For example, you're the CEO of a company, and you wanted to really have dashboard and views of what's happening in your company in different departments, so that you could gauge and steer the company in the right direction. So analytics is actually inferring information, right? You have information coming from multiple sources. You may actually get part of information for analytics in a dashboard, from Oracle. You may also get, information for your analytics in a dashboard, from NoSQL. So I would think of building an analytics on a dashboard is not going to just depend on one system. You really have to interact, get data, consolidate from different sources. I would say, graph databases could be one source of information for creating analytics in a dashboard. I think analytics is kind of, word, that's actually kind of is overloaded. Different people have different meanings for analytics. To me, analytics is more like you're not a technical person, you're really a business manager, and you're responsible for profit and loss. And you wanted to have a global view of what's happening within your company, right? You want high-level metrics that would help you to decide, whether some project should continue or we should scrape a project, introduce a new project. Okay, so here you have which is in a better. So you have Hive, HBase, MongoDB. I think these are really for 3 different purposes. Let's say, for example, focus on MongoDB. MongoDB, the main characteristic for MongoDB is It is in a document-oriented NoSQL system. So what is in a document-oriented? Think about an insurance in a company, automobile insurance company, or even medical insurance in a company. You get documents like doctors may send in X-rays. Doctors may also send in some blood test results. They may also send in results of some other test. They also send some doctors and notes, nurses and notes. So these are actually coming from, you have audio recordings as well. You may have video recording as well. So MongoDB is one where you have all kinds of information coming from, but you want to keep all of them in one place about a particular patient. Whereas in relational databases, you want to keep textual data in one place, audio, video data in some other place. So MongoDB will help you to provide all information related to a case in one place and be able to analyze and be able to explain how you came up with the decision. So MongoDB is more for like insurance companies, for example. It could also be for other places. For example, even if you look at university students in university, previously, if you look at relational databases, you have student mailing address, ID and other information in one place. Then you have student grades in some other place. Right now with MongoDB, you could keep all of it together. So when you want to look at a student record, you have all the information like you would do traditionally before computers came in. If you recall how people in offices used to work on cases, they have various folders, right? You have different pieces of paper in a folder, and one piece of paper is one type of evidence, other piece of paper is some other piece of evidence. That's what MongoDB actually tries to provide, is to provide document-centric way of solving problems. But HBase and Hive, they're really for different purpose. We could analyze them along the lines. You really have to think about what is their core strength in HBase and Hive and MongoDB, and we can't really compare because they're really for different purposes. Okay, so next one is decision tree. If a decision tree is used, is Cypher, okay, Cypher is installed with Neo4j, or we have to install it separate. Actually, when you install, what I have done in my case in a Neo4j desktop, everything is installed in one go. You don't need to, Cypher is actually built into, so for example, here at the very top, I'm not sharing my screen, so I forgot about that. So when you install Neo4j desktop, okay, you have everything, all the tools you need to build an application. Okay, what should be the minimum size of database to shift to NoSQL? I really don't think there's any minimum size. For example, we are doing interactive system for personalized learning. We call it an iSpell. So initially we started using PostgreSQL. Then we realized actually Neo4j is a better match for our needs. So we built the system. Then halfway through we realized we made a mistake. So I would say more than amount of size of data, you need to think about what is the data model my application needs. Some data models quite closely match. Some data models are a misfit, right? If you go to Oracle salesperson, no matter what your problem is, very likely they're going to say, yes, no, we could do that for you, right? But I would not, go with that. So you need to analyze your application, what data model best supports the types of queries you have. I would use that as opposed to the size. As I said, I could actually on my desktop, I could actually have very easily 100,000 vertices and probably close to 500,000 edges, depending on how much memory I have. So size is not should not be the criteria. Okay, so do we have? Okay, so I think we all answered this in a question earlier. Okay, is an decision tree is used in Neo4j? Now, I think decision tree is a different machine learning approach to solving problems. I think what Neo4j does is it actually uses graph algorithms, how to find friends of a particular vertex, friends of a friend. You could also detect communities. That means there are some vertices, they have similar interests. They form a special interest group. You could detect communities. You could also compute path. If I have a vertex in A, what is the shortest path to go from vertex A to vertex B? So those are the kinds of algorithms that Neo4j provides. So Dacian tree is entirely different. It's one machine learning algorithm for solving problems. Okay, so how do I model data using React's key value design? So this is a very simple key value design is a very simple one. For example, you're building a web application where you wanted to keep track of user preferences. For example, I said, this is how my screen should look like. These are the colors, for my buttons, for example. When I come in next time, I want my system to remember my previous preferences, right? Every time you log in, you want your system to remember what preferences you have set. So React is a good model for key value design. So basically, I have a vertex. I don't want to call it a vertex. You have a key. For example, your login ID is the key. And then within that, you will have a lot of key value pairs. For example, name of the person, ID of the person, or you could say, what are the preferences for this particular user for the system, right? I won't be able to talk about what those preferences are. How should your window look like? Should it be positioned at the center of the screen or should it be positioned somewhere else? Those preferences can be stored as key value pairs. So I think React is quite different in terms of its functionality compared to Neo4j. Okay, so did I miss? Okay, yes, okay, there's a question from Sheikh. Sir, what do you prefer, base or ACID? Actually, it's not a preference. If I'm using relational database systems, or if I'm using any system that supports transactions, I wanted to look at ACID properties. To what level of support do they provide for transactions? On the other hand, in a base refers to NoSQL systems and a basic availability, soft state, and eventual consistency. So if I'm looking at NoSQL systems, and I need to examine that system from base perspective. If I'm looking at systems that support transactions, including NoSQL systems, some NoSQL systems support transactions as well, then I would look at ACID for those. So it's really a way of evaluating systems. In addition to CAP, we talked about consistency, availability, partition tolerance. In addition to that, we also use these base ACID. To what degree do these are supported, or these are supported in my system? Okay, most of the systems uses NoSQL, and majority projects use cloud. And I wouldn't really say, I think the question here is, so it's the end of RDBMS. I really don't think RDBMS will go away. It's more like, right, you have extremely rich people in your city or in our state. They're not going to become poor overnight, right? So even if they don't have an income, they're going to take some time, they could live off of what their current wealth is. So likewise, if you look at the established players like RDBMS, like Oracle, Microsoft SQL Server, they're not actually sleeping, in the sense that, remember, we talked about new SQL. They're actually evolving those relational database systems to have the features of NoSQL systems, so that they could remain relevant and stay in business. So I wouldn't say they're going to disappear. Eventually they may disappear perhaps, but it's not going to be, I can't really predict how soon, but they're going to slowly metamorphose into, what, I don't know what the new name is going to be, new SQL, for example. They have the best of NoSQL systems. They also have best of relational database systems. I think many databases are actually progressing in this direction. Let's keep all the good features of relational databases and also bring the new features of the features of a new SQL system, NoSQL systems. So I would say, they're going to be there at least, for next 20, 30 years. There are lots of companies which have heavily invested into relational database systems. Many of their software critically depend on them, and retiring relational databases is not going to be easy. Eventually it will happen. It's like in a COBOL. It was in 1960s, a lot of applications were developed. Still, there are COBOL applications, but replacing them is very expensive, but slowly they're getting replaced. So likewise, I would say, pure relational database systems may no longer exist. They have transitioned to be a blend of relational databases as well as a NoSQL. Okay, so I think some of them are repeated. Maybe because I didn't answer at the time, maybe they thought they had to repost. I'm sorry, I should have answered them when these questions arose. I think I did answer this question, why RDBMS is still important. I think there are some applications where RDBMS is the right choice. RDBMS, if you look at a SQL query optimizer, I think they have a lot of research done over the last 30 years, even for very large scale databases. SQL queries, complex SQL queries can also be answered in less than a second. So if your application is purely relational, the relational data model nicely fits your data, there's no reason why you need to go towards NoSQL, right? Because they have good security model. You could provide different levels of security for different users based on their function. They have good backup recovery mechanisms. So I would think you analyze your application. If relational data model is the right fit, I would stay with RDBMS. I think they will continue to be important, but they, I think it's more like this. In your town, if you have only one movie theater, all people go to the theater. There are some high action movies that require special audio, special effects. Then maybe some theater is built for that reason. So when there's a high action movie, it may be worthwhile to see in that theater as opposed to the old theater. So I think they will all continue to exist, for the reasons elaborated earlier. Okay, so the last question is, after scaling up applications into cloud, can normalization be still ensured? So those who studied normalization theory in the database class, you know that without normalization, you get into a lot of problems, right? You have spurious tuples. You may lose data consistency. You want to ensure, you have redundancy, several different issues, undesirable effects. Okay, normalization can still be ensured, and you don't want to, the level of normalization you would do is to look at the types of queries that you have, and do the normalization to a level that you could process those queries correctly, efficiently. So I wouldn't, if you really don't care about normalization, for example, if normalization is not important, then I would actually go into MongoDB, where I don't need to normalize my data. My data may be redundant. It may appear in multiple places, but MongoDB is quite good in dealing with those issues. So I would, if I had to do denormalization, I would go there to MongoDB. Okay, so any other questions, comments? Okay, so I wanted to make one comment. I wanted to say, intent of this talk, as I said, is not to make you an expert, but create some interest. Okay, there's life beyond relational databases. There are lots of companies trying to use NoSQL systems, and if you could spend maybe a week or so to learn, install Neo4j on your desktop, play with it. I think the best way to learn is to create a simple application. Maybe you could create an application for your university. You have, a hierarchical organization, you have departments, you have courses, you have certain, mechanical engineering students take certain courses in certain order. Some are required courses, some are optional courses. You could maybe create an application like that. And you learn so much, by creating an application than reading. Reading, you need some basic knowledge, but you learn a lot more by doing things. Okay, so my pleasure. And I thank you all for joining. I hope your time on this webinar is worthwhile. We have so many things going on in our lives, and taking time Saturday evening is, I hope I did give some value for your time.
Thank you, Dr. Gudivada, for the
Oh, my
wonderful session.
pleasure.
It was really very in-depth session you have taken on graph databases, also on the NoSQL systems.
Right. Okay.
So it was really a very good session. So now I request our director, madam, for her comments, please.
Thank you, Professor. It was very nice to be with you in this session. Though I don't belong to your fraternity, I really enjoyed the session and understood quite a bit out of everything that you shared. I remember that many years back, we first heard the word RDBMS. And we were very fascinated of RDBMS word and then relational databases. But now everything is changing, and that's changing so fast at a very faster speed. It is said that like your life or your career, your progress, everything depends on how fast you respond to the changes those are occurring around you.
Right.
So computer is the best example. I think your field is the best example for practically demonstrating or illustrating this fact of life, that you should be very quick to respond the changes in the field those are happening. So like, as you told, that there is nothing pure relationship that is existing in the database, but it's a blended. Now education has also become blended. Now we
Correct.
are also like blended offline and online things. So like we are learning a lot, and everything every day we have to go on adding in our information, in our knowledge, in our enlightenment. So like,
Right.
thank you very much for enlightening all our students and all of us basically for the graph databases. It was wonderful. Thank you so much.
Yeah,
I look
thank
forward
you.
to join tomorrow's session.
Thank you. So I just have a quick comment, Dr. Latkar, is you're the director of the institution. In a couple of things, one is, mechanical engineers, civil engineers, their
Yes.
jobs are also so much, need computer science. So when I teach a course, and I taught a course in machine learning, I had, students, PhD students, from physics department, took that course. I also have students from psychology. So I think, you may want to think about, under your leadership, some courses like machine learning, basic,
Sure.
computer science knowledge may be needed,
Sure.
for mechanical engineers and civil engineers. In
Sure.
an extreme example is I was, watching what's happening at Stanford University. They had courses like database management and machine learning. I heard that, lot of students, more than computer science students, they had students from other disciplines in the course, even natural language processing, for example. So I think you may want to encourage, interdisciplinary other students, taking
Yeah.
courses from computer science, not all, but select courses. That way you enhance the job, ability to really do different things on the job, and also innovative things on the job as a mechanical engineer, for example.
Yes, yes. I'm happy to inform you that in our university, we are introducing majors and minors. So
Okay.
minors are, the subjects which the
Correct.
students from other branches can opt and can be. So like mechanical engineer can opt for something to learn in Python and maybe machine learning, and he can be a better mechanical engineer.
Right, right. And also, one other thing I mentioned early on is, like, for example, people talk about IITs in India.
Yes.
To me, I think they're great institutions. But, students who go there, they can learn by themselves. They don't need to necessarily, the IIT provides an environment. It's not necessarily the professors, who teach them. They create the environment in a way they could learn. I think, we have challenges in other types of institutions where, students are not as well prepared. But how do we actually take such students and really give them the knowledge and skill so that they could succeed in their life? So that's the goal, we have, is to make, courses, as less, lecture intensive as possible. So that's something, that I could work with your institution, how we could actually bring more student engagement and student interaction in the classroom as opposed to passively listening to lectures.
That is great. Thank
Yeah.
you so much, sir.
Yeah, my pleasure.
You're most welcome to be with us.
Oh, okay.
Thank you, sir.
Yeah, my pleasure. So yeah, nice seeing you. Now because of my visit, I recognize so many faces. Yeah, it's nice seeing all of you. Yeah. Okay.
Thank you for your valuable time you have given to us. We look forward for your tomorrow's session.
Yeah. Okay. So we'll see you all tomorrow.
Please share the presentation slides also.
Oh,
Yeah,
okay.
if you have
madam,
given
yes.
to me, I will send it to your email.
Yeah. Tomorrow for the tomorrow session. Yeah.
Okay. I'll email it to you later tonight. Yeah.
Okay, sir.
Yeah. By tomorrow morning, you'll have them. Your time. Yeah.
Sure.
Okay.
Thank
Thank
you.
you.
Thank you.
Now I request Bisen sir to share his vote of thanks.
Hello everyone, I am Junaid. It is indeed my pleasure to extend the vote of thanks on this wonderful webinar session on solving large-scale relationship-rich data problems using graph database system, presented by Dr. Venkat M. Gudivada sir. Utilizing time creatively is a lockdown situation is indeed a challenge, but the Department of Computer Science and Engineering is known for overcoming challenges. Keeping the trend, CSC department had organized this international technical webinar, and this could happen just because of the able leadership of our respected director madam, Dr. Geeta Latkar madam. It is my pleasure to thank Director Madam for always being there as a guiding force for such programs. I further take this opportunity to offer bouquet of thanks to our head of CSC department, Dr. Archana Rajurka Madam, whose positive vibrations always encouraged us to work as a team. Her dedication added another milestone in the history of MGM by arranging a series of webinars. I now like to express my sincere gratitude and appreciation for the speaker of today's webinar, Dr. Venkat sir, who had explained today's topic in a wonderful and energetic way. We hope the same help and support from him in future also. Last but not the least, I along with my coordinator, Mr. Rahul Singh Bisen sir, and student technical team, Kartiki, Abhishek, Varad, Sumit, Nikhil, Gargi, Purva, Furkhan, and Mubashira. Thanks all the participants who had spared their valuable time to attend this webinar. I also thank those who directly or indirectly contributed for this webinar project. Thank you everyone. Now there is one short announcement for all the participants of today's webinar that we will be sharing feedback forms link in the chat and WhatsApp group. Spare some time to give us valuable feedback. This feedback is not only important for us to improve further, but also equally important for you also, because as you fill this form, your e-certificate will be mailed to you. It may take almost 2-3 days to get e-certificate to all the participants. Thank you very much. Thank you everyone. Over to you, madam.
So thank you one and all. Shall we disperse now? Rahul? Okay then. So we shall disperse now. So thank you, Professor Gudivada.
Yeah, my pleasure. Thank you all.
Yeah. See you
Thank you,
tomorrow.
sir. See you tomorrow.
At
Yeah.
Okay,
5.
good night. Yeah.
Okay.
Thank
Good
you, sir.
night.
Thank you so much.
Thank you. Thank you, madam. Thank
Thank
you,
you,
one
madam.
and all.
Yeah.
Yeah.
Thank you.
Thank you,
Anand.
Dr. Madam.
Okay. See you all.
Next, of course,